Hello guys, welcome back to another one. So in this one, we're going to look at Kruskal's algorithm. Firstly, we're going to define what it is, and then we're going to do a nice exam style question, yeah, which is suitable for A levels and any other courses you guys are doing. So let's go ahead and define it, yeah, and also define a minimum spanning tree because that is really important for this algorithm. Now, what is it? Well, Kruskal's algorithm is used to find a minimum spanning tree. And before we know what that is, a minimum spanning tree is basically a tree that connects at every vertex. So it doesn't have to basically become a cycle. It's just a natural tree that hits every single point on your graph. It's also, because we're using the word minimum, this means that the total length of the arcs has to be as small as possible. So we want the shortest route. Now looking at Kruskal's algorithm, if we're using this, the arcs are selected by weight and may not be connected until the end. So this is what we're looking at. So we're just going to firstly order every single arc from a graph in order from the smallest value to the biggest. And then when we start the algorithm, we always start with the least weight. Okay, so that's pretty much the summary of it. Now let's look at an actual exam question and try and apply this method. And it's going to come naturally, guys, so don't worry. When you use the algorithm, it becomes so easy. So let's try out this exam right here. So it says to use Kruskal's algorithm to find a minimum spanning tree for this network. List the arcs in the order that you consider them and state the weight of your tree. Okay, so it's straightforward, yeah? So before I start this question, I always like to put a little table here because it helps a lot. Arc and also length. And this helps a lot to organize our train of thought and stuff, yeah? So what we want to do is just basically put the arc pretty much from the smallest value onwards, yeah? So looking at all this, we can see that 4 is the smallest, and that is length. That's from arc ED. So you can say arc ED, and the length is 4. So we just tick off as we go because it helps a lot. The next smallest number will be 5, and there's 2 of them. It's at EA and BC. So we say EA and BC both have a length of 5, and then take them off. And the next one will be AD and DB. So I always look at the arcs from left or right because it's easier to see. So AD and DB, which is 8. In the exam, it's helpful if you use a pencil, honestly, because then you can just rub it out because you'll probably need these numbers. It helps us to double check. Now, all you want to do, according to Kruskal's algorithm, is start with the least arc of the least weight. So we have no choice but start with ED. If you have 2 arcs, then you could choose either, like, suppose 5 was the smallest, then we could either start at EA or BC. It doesn't matter. So let's start here. So what we're going to do, we're going to basically we have to always resketch it. So we're going to start with ED, which is 4. So we have to start sketch it like this, ED, and just label that 4. And then we just take it off. Next, we want to pick another one. So we want to pick, I don't know, anything else. We want to make the smallest possible. So from ED, we can see we can go to EA, isn't it? So I'm going to highlight as we go. We can try either EA or BC. I'm going to do EA. That's going to be over here. So that's 5 EA. Remember, we want to make sure we hit every vertex, yeah? Another one we can choose is BC because it's also 5 because we're covering B and C. So B and C is over here. So C and B, which is 5. And now all we have to do is basically connect it. So notice how we covered all 5 points, yeah? Remember, there's 5 vertices. There's A, B, C, D, E. We just have to connect it either at D, B, or A, B. But because we want a minimum, we want to pick the one of the 6. So we're going to highlight this row. And there we have it, guys. We literally have an entire tree. A tree just means it's connected at every point. Yeah, and that covers everything. We covered pretty much every single point, and we found a minimum spanning tree. Now to find the weight of the tree, and it says here, list the arcs in order that you consider them. Well, we firstly considered ED, which is 4, so we could say the order. We did ED, and then we did EA, and then next we did BC, and then finally we wrapped up at DB in this order, yeah? So you could do an order of that way. And then finally we can say that the weight, which is very important, it just means you sum it all up, is going to therefore be, let's see, 4 plus 5 plus 5 plus 6. And if you add it up, you should get a weight of 20. And that's literally it, guys. That's how you do Kruskal's algorithm. Of course, when you have a bigger tree, it gets a bit more complicated, but this is just pretty much how to understand it.